Question number 19 says the ratio of the arithmetic mean and geometric mean of two positive numbers a and b is m upon n. Show that a is to b is equal to this. Okay. Ratio of the arithmetic mean and geometric mean of two positive numbers. Okay. A and b, a comma b are greater than 0 and the ratio is equal to m upon n. That's what the person is saying, right? No. Of two positive numbers, the arithmetic mean, ratio of arithmetic means to geometric mean. Okay. Two positive numbers a and b. This implies arithmetic mean will be a plus b by 2, comma geometric mean will be square root of ab. And it is given that a upon g is equal to m upon n. Okay. What else? So this can be written as a plus b by 2 root ab is equal to m upon n. This is what I know. Yes? Yes. Okay, since the numbers are positive, a upon this will be root of a by b plus root of b by a, and you have 1 by 2 outside. This will be equal to m upon n. Let square root of a by b is equal to new variable t. If you assume this, then we have simply divided and separated them out, and now we want to make a quadratic in terms of root a upon b. What does that tell me? 1 times 1 by 2 times t plus, this is reciprocal, 1 upon t is equal to m upon n. And this further tells me, okay, t square plus 1 times n, t square plus 1 times n is equal to 2tm. And this becomes nt square minus 2mt plus n is equal to 0. This is what you get, right? What will be the value of t? T can be found using the quadratic formula minus b plus minus under root of b square minus 4 into a into c upon 2a. You can see 4 under root will be 2 and 2 will get cancelled. This leaves us with m plus or minus under root of m square minus n square over n. This is what remains, right? But what is this value? This is t. This is square root of a upon b first of all. Okay, we can choose m plus or m minus. We can choose either one and continue further, right? We need to square this expression. Yes, we need to square this expression. So let's move ahead and see. This tells me a upon b is equal to m plus square root of m square minus n square upon n and its square, or a upon b is equal to m minus under root of m square minus n square upon n and its square. This is equal to this or this. Now what do we do? So this is m plus, and do you see that we need a single m plus and m minus in the denominator, right? So we need that kind of expression. This is what we have. So m plus this, what is that? Where does that take me? This is m plus square root of m square minus n square times this very expression, right? Okay. And I want to rationalize one of these, right? So I multiply and divide with, n is already there, m minus square root of m square minus n square. I divide with this and I multiply the other expression by this. Since there is a square over there, yes. Okay, this becomes n square over here. And when I multiply this with this, what do I get? M square minus m square plus n square. This goes away. This is n square, which further gets cancelled with this n square. Yes, and what remains is m plus under root of m square minus n square upon m minus under root of m square minus n square. This is the value of a upon b that is required, but you will get another value, or a upon b, similar steps of rationalization of one term in the numerator will give me m minus under root of m square minus n square upon m plus under root of m square minus n square. Right. So are these both correct? Yes, these both are correct. The ratio, when the person says the ratio is to be found, the ratio of the two numbers a and b, it is not given which of these is greater. If a is greater, if b is greater, so we can get this or this both as the possible answers, and that's the complete proof for this one, right? Show that this a is to b is equal to this. That's what we have done. But you should be aware, okay, this can be equal to this as well. Is that all? Yes. Is there any other thing given in this question to differentiate between these two? Frankly speaking, no. The ratio of the arithmetic mean and geometric mean of two positive numbers a and b is m:2n. There's nothing else given other than that. And that's all that you have in this question.